All right, so if you've ever gone shopping for a computer, you've probably seen the term SSD thrown around. But there's this hidden detail inside that little acronym that can totally change an SSD's price, its speed, and even how long it's going to last. And it all comes down to one thing: whether or not it has DRAM. So today, we're going to settle the score. DRAM versus DRAM-less.
And yeah, this is the big question, right? You're browsing online looking for an SSD, and you see some that are way, way cheaper. And yep, those are usually the DRAM-less ones. So the question is, are you actually getting a good deal, or are you maybe buying a drive that's going to be slower and maybe not even last as long? Well, by the end of this explainer, you're going to know exactly what to look for.
Okay, so to really get the difference here, we need to pull back the curtain a little bit and look at this kind of secret process that's happening inside every single SSD. It's this constant, behind-the-scenes data shuffle that's, well, it's absolutely vital for the drive's health and its speed. You might think that your SSD just puts a file in one spot and that's it. It just leaves it there. But no, that's not how it works at all. See, the memory cells inside an SSD, they're kind of like tiny little batteries, and every single time you write data to them, they degrade just a little bit. So, to stop one part of the drive from wearing out while the other parts stay brand new, the drive is always, constantly moving your data around. And this whole protective strategy, it actually has a name. It's called wear leveling. The best way to think about it is like rotating the tires on your car, right? You do that to make sure they all wear down nice and evenly so they last longer. Well, your SSD is doing the exact same thing with its memory cells to get the most endurance and longest lifespan possible. Okay, but wait. If your files are always on the move, how in the world does the SSD find anything? Well, it needs a map. A constantly updated, super high-speed digital map that tells the drive's controller exactly where every single piece of your data is physically located. And this map is the key to everything. And that brings us to the two very different ways an SSD can handle this super important data map. This difference is what defines our two contenders today: SSDs with DRAM and, you guessed it, those without. So, an SSD with DRAM, it gives that map its own dedicated, crazy fast memory chip. That chip is the DRAM. Think of it like having its own built-in, top-of-the-line GPS. Now, a DRAM-less SSD, it has a couple of other options. It could store the map on its main storage, the much slower NAND flash. That's kind of like using a clunky old paper map. Or it can borrow a little piece of your computer's main memory using a feature called Host Memory Buffer, or HMB. That's sort of like borrowing the car's main navigation system. I mean, it works, but it's just not as fast or dedicated as having its own.
All right, let's get to the main event. It's time for a 4-round showdown between these two types of drives. We're going to compare them on the 4 things that really, truly matter to you: performance, price, power, and of course, durability. Round 1, performance. And wow, this one is a knockout. DRAM is something like 100 times faster than the NAND flash, where your actual data lives. So keeping that map in the super fast DRAM means the SSD can find data almost instantly. And this is really, really crucial for all those little scattered things your computer is doing all the time, which makes a DRAM drive feel so much snappier in just your everyday use.
Okay, round 2, price. And here, the DRAM-less drive lands a really solid punch. See, adding that dedicated DRAM chip, it's not free. It typically adds, say, $15 to $35 to the cost. Now, for your one home PC build, maybe that's not a huge deal, but just imagine a company that needs to deploy 10,000 new machines. All of a sudden, that cost difference becomes massive.
Round 3 is power. And this one is actually a surprise win for the DRAM-less drive. I mean, you probably don't think of memory as a big power hog, but it is. As researchers over at Carnegie Mellon pointed out, DRAM can consume a ton of energy. The thing is, those chips need a constant electrical refresh just to hold onto their data. So by getting rid of that extra DRAM chip on the SSD, you save power. And that's a huge win for laptops, tablets, and even those giant energy-conscious data centers.
All right, so after those first 3 rounds, let's look at the tail of a tape here. The SSD with DRAM, it clearly wins on performance, no question. But the DRAM-less drive, it's the undisputed champ for price and for power consumption. And that brings us to the final and maybe most critical trade-off, durability. You see, an SSD with DRAM generally lasts longer, and that's because looking at the map doesn't wear down the main storage cells. But on a DRAMless drive, every time it looks at that map, it adds just a tiny bit of wear, which could potentially shorten its lifespan.
So, okay, after that whole 4-round battle, how do you pick your champion? Which one is right for you? Well, it all comes down to what you're actually going to be using it for. So let's break down the perfect use cases for each one.
So when should you absolutely 100% pay the extra cash for an SSD with DRAM? Well, if you're doing demanding work, I'm talking graphic design, video editing, maybe AI and data analysis. If you're a competitive, high-end gamer where every millisecond counts, or if you're managing massive databases, for these kinds of tasks, that performance edge you get from DRAM isn't just nice to have, it's a must-have.
But, and this is a big but, a DRAM-less SSD is often the smarter choice. For just your everyday stuff, browsing the web, using office software, you honestly probably won't even notice the difference. They are a fantastic way to save some money on a PC build, and because they use less power, they are perfect for things like tablets, small devices, and those big company-wide deployments where cost and energy efficiency are the name of the game.
But wait, the story doesn't end there. That nice, clear line we just drew between our two contenders, it's starting to get blurry. Technology is racing forward. So what does the future of storage actually look like?
For years, DRAMless was basically just another word for slow. But that whole assumption is being completely shattered. Companies like Phison are now building these incredibly powerful DRAMless controllers, like their E31T, that can handle the absolute latest Gen 5 speeds. We're starting to see drives that deliver top-tier performance without the cost and power hit of having that DRAM on board. And this really brings us to our final thought here. As the controllers inside these DRAMless drives get smarter, and as technologies like host memory buffer get faster and faster, that performance gap is shrinking. So the question really isn't just which one is better today, it's will this choice between DRAM and DRAMless even matter in a few years? It's definitely something to think about. Thanks for joining me on The Explainer.